here we go. So we're dividing 10022 divided by 103 in base 4. So we're at the pinnacle here. We have done everything in foreign systems, haven't we? We started back with Roman numbers, which you kind of already knew, and converted those back and forth. And then we did Mayan, which was new to you, I'm sure, and that was base 20. And so we started thinking about the fact that we have a place value system. Romans don't. The Roman system was not place value, but the Mayan system was. I don't know if you remember, that was a base 20 system. And then we started thinking, oh, okay, we have a place value, kind of like Mayan, but ours is base 10. And so we started looking at other bases at that point to get an idea of what our base system was like. We converted back and forth between base 10 and foreign bases, and then we counted in foreign bases, and then we added, subtracted, multiplied, and now finally the pinnacle of the mountain, we're dividing. This is the last thing we're going to do in foreign base systems. On Friday, we'll move on to something else. This is our last action in foreign bases, dividing. That's the hardest thing to do. All right, how do we do it? Well, I'm going to do it long division in base 4. So here, let me write it out that way for you. There we go. How do I actually do this long division in base 4? Hey, let's pretend it's base 10 for a second, because that'll be a good refresher. Let's just pretend it's base 10. What if this was a base 10 problem? Let me jog your memory. How would I do this problem if it was base 10? What would be my first step?
You would have to find out how many times 103 could go into 10,022.
Right. Yeah. So what do you guys think? How many times does 103 go into 10,022? Let me ask this. Do I do the whole 10,022 right off the bat?
No, because you can't divide 103 into 100. So you would have to divide 1,002 by 103, right?
Beautiful. Yeah, you go into what you can first, huh? 103 doesn't go into 100. If this was like 104, I would do it, wouldn't I? I would go one time, right? If it was 104, I would say, oh yeah, 103 goes into that. Or maybe if this was like 110, then I would do it one time, and that would be 103, and then I would subtract, right? But it's not. It doesn't go into 100, so then you got to go further, don't you? You go into the first number that you can fit into, right? So 103 does go into 1,002. How many times?
We get 9.728, and then between more numbers.
Did you do that off the top of your head?
No, I would calculate it.
Yeah, it'd be 9 times, wouldn't it? Yeah, we would say 9. And where would we put the 9? We would put it right here over the last digit, because the lineup matters, doesn't it? And we know why, because we're in a place value system. So the places are very important. So you would put the 9 over the last digit of the number you're going into. And we're going into the 1,002. And so now what would I do from there? Wouldn't I have to figure out what 9 times 103 is? So I do that over on the side, right? It's coming back. I know we all just use the calculators, and it's probably been a while since you've done long division by hand. So I'm kind of jogging your memory. So 3 times 9, 27. You can use calculators on everything, but calculator can't do base 4. You can use it to help, but you're still going to need to do the base 4 stuff. So 9 times 0, 0, bring down the 2. 9 times 1 is 9, be 927, right? You can just do that on your calculator for sure. And then where would I write the 927s? Right there, isn't it? 927. And then what do I do?
You subtract them.
Exactly. Now we've got to subtract. So now I can't take 7 from 2. I start over here. I can't take 7 from 2. So what do I do?
You have to borrow from.
You have to borrow, and you can't borrow from these. You're broke friends, right? So we go all the way to the 1, make it 0, and bring what do we borrow over? What do we borrow in base 10? 10. And because you always borrow the base amount. In a minute, we're going to do this in base 4. So we're going to borrow 4, not 10, right? That's what we've learned is you borrow the base amount. Anyway, make that 9, bring 10. 10 now, and make that 9, bring 10. So this will become 12. 12 minus 7, 5. 7, there we go, 75. Bring down the 2. Do the next step. That's enough. I just wanted to get us started. That's how we would do the problem in base 10. Remember all that? So now, let's do the real problem. Same basic idea, but not in base 10. In base 4, as they asked us. So 103 into 10022 base 4. So here we go. Same basic idea. You can't go into 100, so you got to go into 102. How many times should we just go? Is the 9? You've got to do the places here. Is the 9 good again? Should we just do the 9? We're doing base 4 now. Now we're doing the actual base 4. Do you think 9? Do you think it's going to be the same starting spot with a 9?
No, because if you're in base 4, you can't have an answer higher than 4.
Yeah, you can't even have a 4, let alone not. Yeah, you're never. That's right. Good memory. You're never going to see a 4 or higher. No, so it can't be a 9. That's craziness. What's the highest thing it could be?
3.
3. 3. Do you think it's 3? 3. What's 3 times 103? That's just 309, right? That's not right. 1,000 minus 309? It's got to go in more times than that, doesn't it? What's going on here? Is that right? Am I doing this right? That seems crazy, doesn't it?
Wouldn't you just keep subtracting the number over and over and just continue to add numbers that are below 4?
Well, I'll give you a technique. That is one way. I'm going to do it a little different. But tell me this. What's wrong with what I just did? There's a mistake on the screen. What is it?
The place that the 309 is at.
The place? It's this. There's no 9s, remember? That's not right. That's not correct. So anyway, I'm showing you all the problems. I'm showing you all the problems so that you understand this is pretty difficult. And we're going to have to, the problem is what is 3 times 103? And how do we know it's really 3? All right, so that's enough with me showing you the difficulties. Let me show you what you actually, because of all these, I want to give you the reason, because of all these difficulties, because of how hard it is to think correctly about long division in a foreign base, it's so unnatural for us. What we have to do is we have to grab this 103 right here and go off to the side of our paper, and we've got to do our times tables with the 103. So I'm going to have to take the 103 and add it to itself, because I've got to figure out what is 2 times 103. What is 3 times 103, right? Right now I'm trying to figure out 3 times 103. How I'm going to figure that out is exactly how we did back for the multiplying. I'm going to repeatedly add the 103, right? 103 plus 103, whatever that comes out to be, that's 2 103s. That's 2 times 103. And then I'll add another 103, and then I'll have 3 times 103. All right, here we go. 3 and 3 makes 6. Now, here, let me make this a little bigger. I don't think I left enough room for us. Okay, so 103, 103. 3 and 3 makes 6. But we can't have a 6 in base 4. What do I do?
You would have to subtract by 4 and then carry.
Yeah, subtract 4 leaves a 2 and carry. Good job. Yeah, remember that? In base 4, you're always carrying or borrowing, if you're subtracting, the base amount, base 4, right? So when you carry 4 in base 4. So then next column, 1, 0, 0, that's just 1. Next column, that's just 2. So there we go. 2, 1, 2. Now what is that? That's 2 times 103, isn't it? See how that's 2 times 103? Because that's 103 added twice. So we're building our times tables. Notice it's not 206 like you might think, like I would think. It's 212 because it's funny in base 4 because of the carrying. All right, let's do it. The next one. Let's add, whoops, not that. Let's add 103 again. We got to just keep adding 103 because 103 is what we're dividing by out here. We got to find out what is 2 times 103. What is 3 times 103? So here we go. Let's add another one. 3 and 2 makes 5, but we're never going to see a 5. In base 4, you're never going to see a 4 or higher. So cross it out. Subtract 4 leaves a 1. Carry to the next column, right? 1 and 1 and 0 makes 2. And then 2 and 1 makes 3. 3, 2, 1, that's 3 103s, isn't it? And so now we're ready. We have 3 103s. We have 2 103s. Hey, why am I going to stop there? Why don't I go on to do the next one? Why don't I add another 103 and find out what 4 times 103 is? I'm not going to. Why not? Why don't I need 4 103s?
Because we're only trying to figure out the 3.
Yeah, because we're in base 4. We're never going to see a 4, huh?
Yeah.
That makes sense? There's not going to be a 4 in base 4. So we're done at 3. Does that make sense? Everybody seeing that? You only go up to 1 below the base number. So if you're in base 6, you only go up to 5. You're never going to see a 6. If you're in base 5, you only go up to 4. You're never going to see a 5. If you're in base 4, you only go up to 3 because you're not going to see a 4. So we're done. We've got our times tables. We're ready to go. Now let's go back to the problem. Back to the question. Whoops, sorry. What is 3 times 103? Right there, huh? 3 times 103 is 321. So it's 321. Let's do it. 321. Was that correct, or did I just make a mistake in the way I wrote that? Can't do that, right? I've got to make the 321 end in the spot where I put my number. The places are very important. It's got to be like this, doesn't it? And now I'm going to subtract, right? See how everything's lined up. In long division, the places matter, of course, because we have a place value system, which you know quite well now. I wrote this 3 over the last digit of the number I'm going into. Everybody see that? I'm going into the 1002. So you write the number over the last digit, and you have your number in that spot as well. All right, let's subtract those numbers. So 2 minus 1 is 1. And 0 minus 2, I can't take 2 from 0. So you know what I got to do? I got to borrow. Go all the way over here, borrow, make that a 0. And how much do you borrow to the next spot over?
4.
4, because we're in the base 4 system. And then you got to borrow from that 4, make it 3, bring 4 to the next spot. You're always borrowing 4 in the base 4 system. Now 4 minus 2 is 2, and these guys are both zeros now, right? 3 minus 3 and 0 minus 0. I'm not even going to write those zeros. I'm just going to go with the 2, 1. Is that good for the first step? Everybody see how I did that? What do we do now? Bring down the 2, and we're ready for another step. So here we go. What am I going to put here times 103 that'll make 212? Yeah, it's right here. That's why we did these times tables, repeated adding times tables ahead of time, because we're going to need them to do long division. So 2 times 103 is 212. So there we go. 2. So 2 times 103, 212, done. So what's our answer then?
32.
It's the 32 at the top, isn't it? The answer is the 32. And we're finished. There we go. That's how we do long division. Questions I can answer. We just did long division in base 4. And notice how we did it. The first thing to do is to take the number you're dividing by, go over to the side and add it to itself 2 times, add another 103 3 times, etc. You got to get up to 1 below the base number, and then you use those to carry out your long division.
I have a question.
Uh-huh.
So will these numbers always be whole, or our results will always be whole, or will we have like decimals sometimes too?
A good question. No remainder,
No remainders? Okay.
no decimal. Yeah, I didn't want to make it too painful. It's kind of painful enough. Yeah, good question. All the ones I give you will have no remainder and no decimal. So if you're getting a remainder, then you made a mistake somewhere. Go back and check your work. And this is what that means. And I'll be glad to answer questions at the end for the ones you're having trouble with. But yeah, there should be no remainder, no decimals on any of these questions.